Kia ora, and here are the last three questions from question 3 in the 2017 differentiation exam. So 2 achieved questions and a merit question in here. Right, this first one is a little example of the product rule. So we're going to differentiate this function. So we might start, I'm just going to write down the product rule. Now I don't use this as u v dash plus u dash v. I don't use u and v explicitly. I do it by thinking about the first and the second function in there. But if you need more practice, it's a good idea to start with the u and v thing. So dy by dx is going to be the first function, x times the derivative of the second. So the log, natural log, differentiates to 1 over the thing. So it's 3x minus 1 times the derivative of the inside function, which is 3. So that's using the chain rule, right? Plus the next one is going to be the derivative of the first, which is 1 times the natural log of 3x minus 1. Now you don't have to simplify your answer, but I can't stand leaving it like that. So we'll clean it up. We get 3x over 3x minus 1 plus the natural log of 3x minus 1. Okay, on to the next one. We need to find the gradient of this curve at the point 2 1/4. So the first thing we're going to do is we're going to differentiate, and then we're going to sub in x equals 2. So let's start out with the differentiation. Before I do that though, I'm going to write y with negative powers. Makes it much easier. Y is equal to x to the negative 1 minus x to the negative 2. So dy by dx is negative x to the negative 2 plus 2x to the negative 3. Writing that back like this makes it easier to see how to substitute. So at x equals 2, what do we get? Well, dy by dx will be negative 1/4 plus 2 over 2 cubed is 8. So negative 1/4 plus 2/8, which is 0. Now this last question is a really nice one because it covers lots of the big ideas in calculus. It's very easy to get merit on a question like this if you know what you're doing, because you just have to get 3 out of the 5 things correct. What you've got to do though is look quite closely at the graph and make sure that you're not missing anything really obvious. So well, that's what I usually find the biggest problem is. So we've got 5 questions here. This one's about the gradient. Where is the gradient 0? This one's about where is the function continuous but not differentiable. Number 3 is where is the function not continuous. And number 4 is about concavity, the change in the gradient. The last question is asking about what a limit is. So find the limit value of the limit of the function as x is going to negative 1. Right, so we're going to look at where the function's going from both sides, and we'll see if it's going to the same place. All right, so starting back with number 1, where is the gradient equal to 0? Here's one place where the gradient's equal to 0, so that's at x. Oops, I don't know what happened there, sorry, just a sec. X equals 2, and then here, all of this bit along here, the gradient's also equal to 0, so that's where x is less than negative 2. Now notice it's not x is less than or equal to negative 2, and that's because there's a kink in the graph at negative 2. So that's one of the places that answers my next question. At negative 2, because the curve goes like that, I can't differentiate at that kink because the gradient is very different on one side from the other side. So where I have things like this happening, my function is continuous. I didn't have to lift my pen, but it's not differentiable. So that's one place where that happens, and here's the other place. So that's negative 2 and 1. Right, the next thing we're looking for is places where the function is not continuous. So I call that the do I have to lift my pen off the page test. So here, the squiggly line that I'm drawing is continuous. Because it's smooth, it's also differentiable. Now if I start going like that, the curve is still continuous, but at the pointy bits, it's not differentiable. So we're looking for places where we actually have to lift the pen. This is one of them. and this is the other one. So at -1 and at 0. Next, we're asked to find where is the change in the gradient negative. So we're looking for where is the function concave down. So that's going to be all values above 1. X is greater than 1. Remember what's going on there. If I draw this parabola, I'll try and change pen colour for this. We're looking at where the gradient is. So here we're going to draw f dash dash is positive. Second derivative positive. So just grab your pen and do something silly like this. What's happening to the gradient? It's negative, but it's getting less negative. As we keep going, the gradient's positive, but it's getting more positive. Okay, so the gradient is increasing. If we've got a parabola like this one, the gradient here is very positive, still positive, but getting lower. At the top, gradient's negative. There. Right, looks like I've drawn some kind of caveman. So this one, this f dash dash of x, is negative. So that's the only place on my graph where I've got concavity happening. Okay, and the last question is to find the value of the limit as the function is going, as x is going towards -1. Let's do this with green. So here, this is what's happening around -1. As I'm moving towards that point, I'm getting closer and closer to 2. Coming from the other side, the function value is getting closer and closer to 2. Those two numbers are the same, so that means that the limit exists, and the answer is going to be 2. The function itself, f of -1, is not equal to 2. It's equal to 1. Right? So the limit and the function don't have to be the same thing. They just have to be the same thing if we're differentiating. Okay, that's tons long enough talking on that question. These are really worth going over, so I'd urge you to grab the new Delta and find a section in there because there's lots of good practice at these concepts. Okay, thanks for watching. I'll come back with the last 2 merit and excellence questions later on today.